This part is very important for the resolution of weights placed on the inclined plane, because in the examination we usually deal with this kind of examples. So there is a force acting on the block, which is the weight, which always exists, and here we will try to resolve the weight into two components. One component is along the inclined plane, so it's like this, and the other component we will make it as perpendicular to the inclined plane. So you can see that in the diagram. So drawing the diagram like this is not that difficult, but the key is how do we use the theta? When you focus on the rectangle, which angle is the theta? This one seems obvious, but actually we can prove it. If you consider the diagram carefully, you should find that we can always draw two triangles, the big one and the smaller one, and they are similar actually. So the angle we marked it here is the angle theta. Then the component that's along the inclined plane will be mg sine theta, and the other components that perpendicular to the inclined plane will be mg cosine theta. So let's see how do we use it. In this example, we want to find the minimum force in each case that can push the block up. So for the first example, there is a weight mg, and we will consider the component along the inclined plane and perpendicular to the inclined plane. Which one is more important to us? For this case, because we want to push the block upward, so we have to consider the direction along the plane. If you still remember, this component can be written as mg sine theta. So the F1 should be equal to the mg sine theta, so that the block can just be pushed up on it. And the other one, we also have the mg that's bringing the block vertically downward, and we also break down the force into two components, perpendicular to the plane and along the plane. And what's the difference here is that the force is applied horizontally. Then how can we relate it to it? Because we are considering how to push the block up, so we have to break down the F2 into two components also. One is along the plane, the other is perpendicular to the plane. And here we focus on the direction that's along the plane, so that the force F2 will be resolved into two, and we will focus on the one that's along the plane, which is the F2 cosine theta. And for the components of the weight will be the mg sine theta. So F2 cosine theta will be equal to the mg sine theta. So by simplifying the equation, we can find that the force required is the mg tangent theta.